students, welcome to VTeach. In the previous class, we have seen inclusion-exclusive principles. Now, in this class, we will see about partition and covering of a set. Partition of a set, say S, is a collection of n disjoint subsets. Disjoint means no elements will be common in that set. Say P1, P2, Pn that satisfies the following three conditions. If they are partition of the sets means they should satisfy the following given conditions. First one. P1 does not contain any empty set. So P1 should not contain any empty set. P1 does not equals to empty set 5 for all I times from 1 to 0 to n. So this Pi is equals to, this is not P1, Pi. Pi should not be equals to empty set. The union of subsets must be equal that the entire original set. So all the sets given union should be equals to the entire original set, that is the whole set given S. The intersection of these two sets is empty set. So intersection of any two distinct sets should be an empty set. For all A is not equal to B, where n is greater than or equals to A and B is greater than or equals to 0. Let's take another example. S1 is equal to 1, 2, 3, 4, 5, 6. S1, S2, S3, S4 and up to S8 they given. So they asked us to check whether the given following are valid or not. X1 is equal to S6, S7, X8 and X2 is equal to S3, S4, S5 and X3 is equal to S1, S2. So let us take for first S1 is equals to X1 is equal to S6, S7 and S8. First, what is the first condition? Those sets should not be equals to null set or phi set. So these three, those are not equals to 0 or phi set. So condition 1 is satisfied. Next, second condition, any intersection of any two disjoint sets should be equals to empty set. X6 intersection S7. So here see, no similar elements are present. So we can say that both intersection will be equals to 5. S7 and S8. Here also intersection of these both elements. No elements are common. So again this is equals to 5. Next S6 and S8. Here also no elements are present as common. So we can write it is an empty set, that is equals to 5. So X6, S8 is also equals to 5. So condition is satisfied. Next condition number 3. S6, S7, S8. If we write the union of these three sets, what we should get? We should get the main set S. So if we are writing the union as 1, 2, 3, 4, 5 and 6, that is equals to the given sample set S, the basic set. All the elements are containing. So all the three conditions are satisfied here. So X1 is an valid partition. In the similar way, let us check for X2, that is S3, S4 and S5. What is the first condition? Individual sets should not contain 5. So any of the sets does not contain 5 value. So first condition is satisfied. Next S3 and S4, that means intersection should be equals to 5. But in these two sets we have the common element 3. So 3, if we are having any common element 3, this is not equals to 5. So condition 2 is not satisfied. What is condition 3? S3, S4, S5. All those three sets, the union should be equals to the given set S. So all the union is equals to the given set S because 1, 2, 3, 4, 5, 6. It is equals to S. So condition 3 is also satisfied. Therefore X2 is not an valid partition because here for us the second condition does not satisfy. Here the second condition does not satisfy. Even though 1 and 3 conditions satisfy, here the second condition does not satisfy. So we can say that the given set is not a valid partition. Now check for X3, that is S1 and S2. S1 is not equal to 5 and S2 is not equal to 5. So we can say that condition 1 is satisfied. Next, first condition is satisfied. Next, what we should find out? We should find the intersection of these two sets. What is the intersection? No common element is present. So it is a null set. So it is equals to 5. So second condition is also satisfied. Next, S1, S2 union. S1 union S2. That is 1, 3, 5 union 2, 4. What can we write? 1, 2, 3, 4. This is not equal to the given set S. What is the set S here? 1, 2, 3, 4, 5, 6. Here the element 6 is missing. So we can say this is not equal to S. So third condition is not satisfied here. So if any one of the conditions is not satisfied, we can simply say that X3 is not a partition set. So in order to prove it is a partition set, we should check all the three conditions are satisfied. If any one of the set is not satisfied or two of the conditions or three conditions, we simply say that the set is not a valid partition. So in this way, we will check the three rules for every problem and we will say whether it is valid for partition or not. Okay. I hope you all understood this simple topic. Thank you, students.